cos raised to the power n of 1 upon n power x. We have to prove that f has exactly one point of discontinuity, and we have to evaluate this f at this point of discontinuity. Let us see how we will do this question. First of all, please understand, because my x belongs to 0 to infinity, that means x is greater than 0. So we can say that n power x, where n is approaching to infinity, will be definitely approaching to infinity, isn't it? Because if x is positive and if we are raising it to some number that is tending to infinity, this value will be approaching towards infinity. Okay, dear all, let me tell you, whenever we have to think about this, we should think this way, that it is limit n approaches to infinity and n power x. Now whatever x you choose, by making n arbitrarily long or large, actually, I think this will always be approaching towards infinity. Some people may think that x, when it is very small, shouldn't it becomes approaching to 1? So dear all, let me tell you, whatever x, however small x you take, by by varying n towards arbitrarily large, this n power x can become infinite. So this, for x approaching to x greater than 0, this limit n approaches to infinity, I can say n power x will be infinite. And 1 upon, again let me write this way, n approaches to infinity, 1 upon n power x will become 0. And if it is 0, I think this cos of 1 upon n power x will be becoming towards 1. Okay, and this 1 is raised to this, raised by n, which is approaching towards infinity. That means here we should be, we are having a form of 1 power infinity. So this cos of 1 upon n power x whole raised to the power n is actually 1 power infinity form. Now to solve this 1 power infinity form, what we can do, we can write this fx to be equal to one very standard case. If you remember, let me remind you that 1 plus fx into raised to the power gx for some x approaches to a, and this for x approaches to a, fx approaches to 0, and limit x approaches to a, gx approaches to infinity. So you can see it is actually 1 power infinity, and in this case there is a standard method. We write this to be equal to e raised to the power limit x approaches to a into fx into gx. I think that is something very standard, we can use directly. There is no need to prove it. Now using this thing, I think this fx can be written as e raised to the power limit n approaches to infinity. Now dear all, this cos 1 upon n power x itself is 1. So to write this in the form 1 plus fx, where fx approaches to 0, I need to write this as cos of 1 upon n power x minus 1 into n. This power will be multiplied here. Okay, now to find this limit, what I will be doing, I'll write this as e raised to the power limit, let me just remove this, e raised to the power limit n approaches to infinity. What we can do, we can rationalize it. Rationalize means I can multiply by cos of 1 upon n power x plus 1, and in the numerator, if I do the same thing, it will become minus sine square 1 upon n power x into n. Okay, now if n approaches to infinity for all x, as I've shown you, 1 upon nx approaches to 0. So what I can do here, I'll write this as limit n approaches to infinity, and this cos 1, the cos 0 will be 1, this will be 1, so we can write this as n by 2 into minus sine square 1 upon n power x, and to make it a standard limit, I think I'll be multiplying and dividing by 1 upon nx square, and I'll be multiplying here 1 upon n power x square, and this way this thing will become equal to 0, because it is sine x upon x form, where x is approaching to 0. So here what we are getting, it will be e power limit n approaches to infinity. This is 1, so I can write this as minus 1 by 2, and the power of n would be 1 minus 2x. You can check 1 minus 2x. Now here the limit will depend upon the value of x. Suppose my x is equal to 1 by 2. If it is exactly equal to 1 by 2, I think this power will become 0, and here it will be 1, because this n power perfect 0 will be 1, so it will be actually e power 1, not 1, it will be e power 1. If I take x greater than 1 by 2, if x is greater than 1 by 2, this power will be negative. 1 minus 2x will be negative. And if it is negative, so infinity power negative, let me tell you, if n is approaching to infinity and there is a power negative, that means 1 upon n power positive. Where n is infinity, it has to be 0. So if it is 0, then I think for x greater than half, this will become 0, and e power 0, that means I will be having 1 here. Now similar to this, if x is less than 1 by 2, then this power will be positive, n power positive will be infinite, and e power minus infinity means it will be 0. E power minus infinity, again I am repeating, as x is less than half, this 1 minus 2x will be positive, n power positive will be infinite, minus half multiplied, so it will be minus infinite, e power minus infinite is 0. So this is how we can see that x is equal to 1 by 2 only. This function is discontinuous. That's the point of discontinuity, and the value of function at this point is e. So if I have to write the answer, let me write it here. For a part, show that this has exactly 1 point of discontinuity. So that point is x is equal to half, and in the b part, the value of function at that point, as you can see, we have calculated, it is coming out to be e. So this completes the solution of this question. Easy question, but little tricky question. It could have been confusing in the exam, because this 1 upon nx could have been little confusing.